This is the warm-up for lesson 16, so we should be able to do this just fine from yesterday's work. What do we notice? We've got a 7 outside and a 4 outside, so we need to get rid of what's outside before we can do our positive and our negative side. So between the 4 and the 7, the 4 is multiplying, the 7 is adding, so what am I going to do? Undo first. I'm going to undo adding first. So I say 4 times the absolute value of 2n plus 5 equals 28. And now what undoes multiplying by 4? Dividing by 4. So now we've got 2n plus 5, the absolute value, equals 7. 28 divided by 4. Now that I've got my one side where it just has my absolute value, now we can make our positive and our negative sides. So our positive side, 2n plus 5 equals 7. And our negative side, 2n plus 5 equals negative 7. And we'll evaluate both of those from here. We'll subtract 5 and subtract 5. 2n equals 2. Divide by 2. And we get n equals 1. On our other side, we'll subtract 5. What's negative 7 minus 5? Negative 12. Divide by 2, and we get n equals negative 6. So we should always be looking to get 2 answers when we're solving these. Today, we'll skip homework questions. Today we're going over lesson 16, absolute value inequalities. So we're going to compare them to a regular absolute value inequation like we did yesterday and what we just did in our warm-up, and they're super similar. So here's how similar they are. When we graph these to solve and graph, we would solve and graph these just like we would when we were having our inequalities from last unit. What do I mean by that? We've got just our absolute value symbol by itself on one side, so we know we're going to have our positive side and our negative side. For our positive side, we just remove the absolute value and we don't do anything to the equation. So this is all real numbers less than 4. For our other side, we're going to remove the absolute value. We change our symbol, so we reverse our inequality symbol, and we make this negative a negative, so that positive 4 becomes a negative 4. So we've got all real numbers are less than 4, but also all real numbers are greater than negative 4. Well, when we start off like this, if we think of ourselves on a number line, we've got negative 4 on our left and positive 4 on our right. We can go back to the negative 4. We're greater than negative 4, so that would be an open circle going to the right. When we look at this side, we're less than 4, so that's an open circle going to the left. What kind of an equation did that make? That just made an AND equation. So I need to rewrite this as an AND equation, and that would be negative 4, positive 4, my variable in the middle. What am I in comparison to negative 4? I'm greater than negative 4 because I'm eating the variable, so we say greater than. What are we in comparison to the 4? We're less than 4 because we're eating the number, and that's how we would write this as an inequality. All real numbers greater than negative 4 and less than 4. That's what this means. So now it's a little bit different. If you'll notice, we started off less than here and we ended up being an AND equation. We're going to be a little bit different here because we're starting off being greater than. So here's what I mean. We've got our positive side where I say m is greater than or equal to 3, and we've got our negative side where we say m. We reverse our inequality symbol and we make this a negative instead of a positive 3, so now it's a negative 3. So now if we were to graph these, we've got negative 3 and we've got positive 3. What are we in comparison to the positive 3? We're greater than or equal to positive 3, so that's a closed circle, and greater than goes to the right. What are we in comparison to negative 3? We're less than or equal to negative 3, so that's a closed circle, and we're going to the left. So what do we do when we have a graph that looks like this? This is now an OR equation. So I don't really need to change it because it's an OR equation, but I do need to write down an OR in between because I'm either a solution to one of them, I'm either greater than or equal to 3 out here, or I'm less than or equal to negative 3, I'm out here. So you guys try these. Solve and graph their solutions. We'll notice when this starts being less than, we know we're going to have an AND equation, and when we start being greater than, we know we're going to have an OR equation, just by how those symbols start off. So we say we've got our positive side, R is less than 5, and our negative side greater than negative 5. If we were to graph this, negative 5 and 5, we're going to be less than 5, so that's open circle going to the left. We're going to be greater than negative 5, open circle going to the right. We look at this graph and we know, hey, this is an AND equation, so we got to do a little bit more to it. We need to rewrite this, put our variable in the middle, make that R a little bit nicer. What are we in comparison to negative 5? We're eating the variable, so we eat the variable. What are we in comparison to positive 5? We're eating the number, so we eat the number. All real numbers greater than negative 5. All real numbers greater than negative 5. That's what my graph says. And less than 5. Less than 5, going to the left. So let's take a look at this next one. Our positive side would be R is greater than or equal to 1. But our negative side would be R is less than or equal to negative 1. When we graph this, well, we've got negative 1 and we've got 1. Less than or equal to negative 1, that's closed circle, and less than or equal to goes to the left. Greater than or equal to 1, that would be closed circle, and greater than goes to the right. So this is an OR equation. So because it's an OR, I don't need to rewrite it, but I do need to write the OR in there. Our next couple examples, just the same as our regular equations. When we have other stuff on the same side as my absolute value symbols, we need to get rid of that other stuff first. So this is subtracting 7, so I need to get rid of that negative 7 by adding 7. So before I can do anything, I need to get rid of that. So now I've got negative n minus 1, or the absolute value of negative n minus 1 is greater than 3. So now we have our positive side and our negative side. Our positive side is going to be negative n minus 1 is greater than 3. We didn't do anything to that. Our negative side, negative n minus 1 is less than negative 3. So we changed the symbol and made the constant negative. What would we do next? We'd add 1 and add 1. Negative n is greater than 4. If we remember, when we divide by a negative, what do I have to do to the inequality symbol? We reverse the inequality symbol, and so now we have all real numbers less than negative 4. And on our negative side, our steps are going to be the same. We're adding 1, negative n less than negative 2. Divide by a negative 1. When we divide by a negative, we need to change this one back the other direction. And negative 2 divided by negative 1 makes positive 2. So now if we think about this, we've got negative 4 and positive 2. What are we in comparison to negative 4? We're eating the number, so we're less than negative 4. And what are we in comparison to the 2? We're eating the variable, so we're greater than 2. So is this an AND or an OR? It's going away from itself, so this is an OR. But you're saying, Mr. Gill, we started off greater than, and we ended up being an or. Is that how we did it before? We started off greater than and we ended up being an or. Look at that. We start off less than and we end up being an and. So let's look at this one. We started off being less than. I think we might end up being an and. Let's see. Subtract 10. Get all that stuff outside of there that we don't want around. The absolute value of negative 2m plus 3 is less than or equal to 11. Now that I've got just my absolute value on one side, we've got our plus side and our minus side. Negative 2m plus 3 is less than or equal to 11. On our other side, negative 2m plus 3. Change the inequality symbol and make that 11 a negative 11. Don't forget to do that. From here, we're solving equations just like we normally would. We're going to subtract 3. Negative 2m is less than or equal to 8. Divide by negative 2. Change our inequality symbol around because we're dividing by a negative. 8 divided by negative 2 makes negative 4. Let me write that a little nicer. Negative 4. Our steps will be the exact same here. Subtracting 3. What's negative 11 minus 3? Negative 14. Dividing by negative 2. We divide by a negative again. We need to reverse the inequality symbol. And that makes positive 7. So now let's take a look at our graph. What will this graph look like? We're talking about being at negative 4 and being at positive 7. What are we in comparison to the negative 4? Well, we've got the equal sign, so we're closed circle. And we're eating the variable, so we're greater than. We've got the equal sign, so we're a closed circle. And we're eating the variable, or we're eating the number, so we're less than. So this makes this an and. Now because it's an and, we're going to rewrite it. We're going to rewrite our numbers in order. Negative 4 and 7. We're going to put our variable in the middle. We're going to go back to what we were looking at. Between the variable and the negative 4, we were eating the variable. So we say we're going to eat the variable. Between the variable and the 7, we were eating the 7, so we're going to continue to eat the 7. And that's an and equation because it's going in on itself. All real numbers greater than or equal to negative 4 and less than or equal to 7. You guys try these. Take a second. Try to do them. So this problem, we're going to subtract 10 from both sides. We get the absolute value of 2m plus 3 is less than or equal to 11. From here we've got our positive side and our negative side. Negative 2m plus 3 is less than or equal to 11. Our negative side, negative 2m plus 3, reverse the inequality symbol. Greater than or equal to negative 11 on this side. We're solving these just like we would. So we're going to subtract 3, subtract 3. Negative 2m is less than or equal to 8. When we divide by a negative, what do we need to do to the inequality symbol? We need to reverse the inequality symbol. And that makes negative 4. So our steps should be the exact same. What's negative 11 minus 3? That makes negative 14. When we divide by a negative, we need to remember to reverse the inequality symbol. And we get less than 7. So now, is this going to be an and or an or? Well, let's check out the graph. If we look at our graph, we've got negative 4 and we've got 7.
Can I make noise or do you want me to come back?
Why don't you come back, please? Just a couple minutes. At -4, we're greater than or equal to -4, so it's a closed circle. And greater than goes to the right. And at 7, we're less than or equal to 7, so it's a closed circle, and less than goes to the left. So this is an AND equation, so we're going to rewrite this. -4, 7, put our variable in the middle. I changed this variable from an m to an x, didn't I? Doesn't really matter, but let's keep it the same, m. We look at this, what were we eating? We were eating the m, so we're going to stay eating the m. What were we eating? We were eating the 7, so we're going to stay eating the 7. And that's our answer. All real numbers greater than or equal to -4 and less than or equal to 7. How did we start off? We started off being less than or equal to, and look what it ends up being. It ends up being a AND equation. When we look at this next one, it starts off being less than, so I'm going to guess that it's going to end up being an AND equation too, but we'll find out. I've got a 3 out in front, I've got a -6 out in front. I need to get rid of these. The 3 is multiplication, the -6 is subtraction. I'm going to undo the subtraction first. 3 times the absolute value of 5r minus 10 is less than or equal to 45. How do I get rid of the 3? I need to divide by 3, divide by 3. My 3 simplify out, and I got 5r minus 10 is less than or equal to 9. From here, now we have our positive side and our negative side. Our positive side, 5r minus 10, less than or equal to 9. Our negative side, 5r minus 10, greater than or equal to, don't forget to reverse the inequality symbol, and make that -9. So now we're solving this just like we would. And we'd add 10, and add 10. We get 5r is less than or equal to 19. Divide by 5, divide by 5. R is less than or equal to 19/5. Well, that's really close to 20. Or sorry, 4. Our other side, our steps will be the same. We'll add 10. 5r is greater than or equal to 1. Divide by 5, divide by 5. And r is greater than or equal to 1/5. So if we were to write these numbers in order, we would have 1/5 is less than 19/5, so 1/5 is over here on the left, and 19/5 is over here on the right. 19/5 is 3 and 4/5. It's only 1/5 away of being 20 over 5, which is 4. So we're only 1/5 from 4. Anyway, what are we in comparison to the 19/5? We're less than or equal to, closed circle, less than goes to the left. What are we in comparison to the 1/5? Closed circle goes to the right. So this is another AND equation. So we're going to rewrite it. 1/5, 19/5. Put our variable in the middle. What were we eating? We were eating the 19/5. What were we eating? We were eating the r. And that's our answer. All real numbers greater than or equal to 1/5 and less than or equal to 19/5. Our homework today is homework 16.